Hi everyone, welcome to this video on P6 waves. So in this video I'm just going to talk through the two types of waves, transverse and longitudinal, and then the electromagnetic spectrum. So two types of waves then, transverse waves. Let's start here. So transverse waves are the ones that you've probably seen the most of. They go up and down, they've got a peak and a trough, and they look like that. So what you need to know about these is that the vibrations or the oscillations, so vibrations, which is another word for oscillations, go up and down for a transverse wave. So because the wave is moving up and down, the vibrations are moving up and down. Now the wave is travelling in that direction, and we say the direction that it's travelling is known as the energy transfer. So vibrations are going up and down, but the wave is travelling in that direction. So vibrations and energy transfer are perpendicular. And perpendicular basically just means at 90 degrees. So you can see here, they're at 90 degrees. This one here is the oscillations, this one here is the energy transfer. The other one, longitudinal, just so you can compare, longitudinal waves look like this. There's lots of lines, some are closer together, some are further apart, then closer together again, and then further apart, so on, so on. So here, where the lines are closer together, we call them compressions. And where they're further apart are called rarefactions. Now the oscillations here go up and down, or the vibrations go up and down, but the energy transfer is also up and down like that. So we say vibrations and energy transfer are parallel. Parallel meaning the two lines will never meet. So they're both in that direction. Okay, so I'll just give you an example of a transverse wave. Transverse waves are, for example, waves from the electromagnetic spectrum, so radio waves, microwaves, visible light, X-ray, gamma, etc. And we'll go through that in a minute. Longitudinal are sound waves. So if you were asked to give an example of those waves, EM spectrum for transverse and longitudinal sound waves. So there's a few labels you need to know, so let me just rub this off for a bit more space. So the transverse wave then looks like this. Sorry, let me do it better. Looks like this, okay? You will be asked to label wavelength, amplitude, peak and trough. So wavelength is the distance from the top of one peak to the top of the other in the centre. So it's really important that you go from the centre of one peak to the centre of the other, and that's wavelength in meters. Okay, so it just means distance from peak to peak. The amplitude, I'll do it here, is from the top of the peak to the middle line, to the halfway point. That's your amplitude. Peak is the top of the wave, and the trough is the bottom of the wave, so either that one or that one. So in terms of frequency, now frequency basically means how frequent those peaks are, how often do those peaks appear in, for instance, 1 second. So something like this, let's say that time frame is 1 second, as opposed to that, and again, that's 1 second. You can see that this one has a higher frequency, this wave has a higher frequency, because you've got more peaks per second, as opposed to that one, lower frequency. We've only got 2 peaks there. so that's low frequency. So just so you're aware, frequency is the number of complete waves passing a point per second. Now there's two equations that you need to know. Sometimes they give these equations, sometimes they don't. It just depends on the question. So the first one is time period in seconds equals 1 divided by frequency, and frequency is in hertz. So you might be asked to work out frequency, you might be asked to work out time. Either way, you need to know how to rearrange this equation. So time period equals 1 divided by frequency. The other one that you need to know is wave speed equals frequency times wavelength. Wave speed is basically the speed that the wave is travelling in meters per second. Speed is often measured in meters per second or miles per hour, etc. But for waves, it's meters per second. Oops, smudged it, sorry. Frequency is in hertz and wavelength is in meters. So I'll just put that into a triangle for anyone who prefers to use the triangle. So that's wave speed, capital V, I'll label it wave speed in meters per second. This one is frequency, and frequency is in hertz. This is lambda, and lambda represents wavelength in meters. So if you're not sure how to use the triangle, let me just quickly go through it then. So how you use this triangle is, let's say I want to work out frequency. You cover the one that you want, you cover frequency, and you do a division for whatever is left here. So going downwards, it's wave speed divided by wavelength. If I want to work out wavelength, I cover the wavelength and it will be wave speed divided by frequency, as it's those going down now. And if I wanted to work out wave speed, I cover the wave speed, but this time, because it's going across, it's actually a time, so it's frequency times lambda.